So again, today we're going to review files. How do we read from a file? How do we read that file's contents into our program and then spit it back out? So if you think about files, it's just like in gaming. Right? So I think all of you all play some form of game. If not a game, then you use Word documents. Right? So what happens is the person who created those games or who created the Word software, they made or gave you the ability to save your work. We were literally just talking about it. You can save your work. When you save your work, it writes to a file. Right? Even in gaming, if you open your save file, it'll have a whole bunch of gibberish in there. However, the program, whoever wrote the program, when it reads in the contents of that file, it knows that format and can read in that data according to how that program is made. And so now as programmers, we're going to learn how to do that. That ability to read from a file, and then on Wednesday, we're going to learn how to write to a file. Okay? So in that vein, let's create a sample file. So I'm going to go to Notepad. I'm just going to create a file. And say, hello world. This is a test file. Sample content contain. And actually, one of the most common phrases that is used to test a lot of different things, quick brown fox. So this is just some content that you can copy in there. Let's see if I can get it. Where's the actual? Is it just quick brown fox? I thought it was an entire saying. Yeah, or the Latin one, which I can't remember how that one starts. Ipsum, yeah. Ipsum lorem, yeah. There we go. So we could put that in there and see how it works. It's going to be all in one line, yep. So let's break this up into multiple different lines. Here, 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 and we're good. I'm going to save this file. I'm going to save it in my project. It just makes it easier. Lecture 15. I'm going to save it inside of that path. And I'm going to name this sample.txt. All right, so our sample file has this information in it. Right? If we put this on the console, the user would have to type all of this out. But instead, we have it in a file, so we're going to read that file in. All right, and this is going to be really helpful because on your lab, I want you all to create the ability, when they close the program, ask them if they want to save their array list. And when you open up your program, read in the contents from their save file. They have to type in what the name of their file is, then you have to read in the contents and put it back into your array list. Okay, so how do we do that? And on top of that, when you read it in, you still give them the ability to add and remove from the array list, and then save their work again. So let's talk about how we read from a file. We have lecture 11 file here. I'm going to rename this to 15, because that's the one we're doing today. And you see we have our sample.txt file right here. I can open this in NetBeans and you'll see all our content. Okay, so here's our old program, right? We give them the choice, either add, remove, or in the program, and they have the choice of doing that, right? This should look familiar to you all. You've done this before. All right. Down here? Which one? Right here? This is just to catch every other exception. It can occur or it doesn't, either way. So I'm going to give them another option. So instead of 2 ending, I'm going to put 3 is to end, 2 is to remove, 1 is to add. Actually, no. Let's start at the beginning, because when you run a program, you're only going to read in most likely one time. And then our program is going to let you add remover in over and over again. So I'm going to prompt them. System.out.println. Would you like to load from a file? I'm going to give them question mark y/n. All right. So it asks them they want to read from a file. We have a scanner for our system. So we're going to say string read choice equals input dot next line. We're going to read in from the console if they want to load a file or read from a file. We're going to say if read choice dot to lowercase. That lowercase is it. If they put in a capital Y, they put in a lowercase. Dot starts with Y. They hit yes. That's the only scenario we want to read from a file. If they hit any other thing, if they hit a no or something else, we want to. Actually, you know what? Let's put in some validation. So while put a while loop up here, so that if they make a mistake, we ask them again, while true, else if read choice dot to lowercase dot starts with in that scenario they hit no, so we're going to break this loop. Else, what do you think I should put in this else statement? What do you think should go in this else statement? So I asked them, would you like to load from a file? If yes, what we're going to do is read from file. If they hit a no, we break the while loop. What else should we say? You had to put the closing bracket for this while loop up here. When you put the closing bracket, you have all your brackets for your ifs and else's. You haven't added the if else's yet. You just have this while loop. While true, open bracket, closing bracket. It still has an error. Unreachable statement or missing. While true, that's because you haven't put a break in yet. So with just a while true, it's going to go indefinitely. So the next statements would be unreachable. But once you put a break statement in there, it'll go away. So if read choice.lowercase starts with a Y, we're going to read in from a file. If read choice.toLowercase that starts with an N, we're going to break. What should we put in our else statement? So if it's not a Y, it's not an N, what should we say? Exactly. Invalid input. System.out.println. Valid input. Y or N. Home. You see, we don't have to put this type of validation checking in here, but it makes our program more responsive, right? It also protects our program from some crazy user input. And even if we want to go even further, instead of starts with, because they could put a yellow and it would still start with a Y, we can say equals. That way it has to equal a Y or it has to equal an N. No other choices. Starts with allows them to put none, and it still starts with an N, and it'll work. Or like I said, they can put a yellow in, it still starts with a Y, and it'll work. When we say dot equals, it forces them to only put in a Y or an N, or it's invalid input. So let's see what this looks like. Of course, I get an error. Class not found. Okay, so my run configuration is not right. Because the class that we were using previously is no longer there. So I got to select a new. There we go. All right, so it says, would you like to read from a file? So if I put a yellow in here, if I can spell yellow correctly, invalid input, Y or in only. If I put a none, invalid input, Y or in only. If I put a capital Y, it should still work. And it didn't work, but it should work. If I put a Y, oh, I know why. There's no code in the Y. If I put an in, it should go on. So I haven't put a break statement in the Y, so it's going to keep going. So we do need to put a break statement here to break our while loop once we read in the file. So a break statement will go in both the if and the else if. However, we do have to put that in if we want to test our program at this point. So if I run this again, if I put a capital Y, it should continue. And it does continue. Any questions about what I've done so far? Any questions about what this code does? So line 23, what does that do? It's the one with the light bulb on it. 25, I'm sorry, line 25. What does that do? Spell it out for me, like I've never coded.
It allows the user to input lowercase yes. Like it has to or y not yes, it has to be y, and it has to be y, it can't be uppercase y or.
It can be an uppercase Y because read choice.to lowercase, it converts it, whatever they put into the lowercase, it converts to a lowercase. And then we check whatever that result is equals a lowercase y. So they can put a capital or a lowercase, but it has to be only a y. Same thing for on line 30. It has to be a lowercase or capital N, but only. So that's what dot equals, the difference between dot equals and dot starts with. Starts with, it just has to start with that N or Y. Equals, the whole string has to equal that character, or that string. That's a dash, yeah, minus. Is that better? All right, so let's read from a file. What do you think we need to read from a file? What else do we use to read? Scanner. No, that was to print. Scanner. Eventually, printing, we'll talk about Wednesday. So writing to the file, we'll talk about. Same scanner. We already imported it one time because we're using a scanner up here. But mind you, when you create a scanner, what you put in these parentheses determines what it's going to read from. System.in, I don't know if you ever knew this, tells the scanner to read from the console, from the system.in console, right? So if we want to read from a file, what do you think we have to put in those parentheses? A file, not just the name, although I think it might work for the name, we have to see, but a file object. A file object can point to a file name, right? And it basically points to that file. So, and let's see if we can just put the file name. Scanner input. So we don't want to use the same scanner because input reads from the console. So let's do scanner reader equals new scanner. Our file name is sample.txt. Yeah, you just don't get confused about which one is which. So putting in the file name does work. It does work, it's fine. However, we want to put some extra protection in here. We got to ensure that that file exists. Right? So if I put sample1.txt and I run this program, and I hit yes, and I guess it works, it just ignores that the file doesn't exist. Because there is no file. Now let's try this. So let's say, so we create the scanner, and maybe it's like, hey, the file either exists or it doesn't. But if we say string line equals reader, and you use the same methods that you used for your previous scanner, and it reads exactly the same way. Next line. That should give us an error, because sample1.txt does not exist. Or an exception, I'm sorry. I guess it just ignores those exceptions. Huh?
I mean, at the bottom of your program, you did the exception for all exceptions.
Yeah, but the try doesn't start until, right, where's the try? The try doesn't start until here. So the fact that this is working, it's baffling to me. Let's see why it's working. This is when a debugger comes in handy.
I'm saying that my break statement
You're missing a bracket somewhere. So let's see, would I like to read from a file? Yes. We go here. It reads the line, and so what does the line equal? I'm so curious. It reads, oh, I was right, okay. I thought so. So when we put this in here, it's literally going to read this string. So the next line is sample1.txt. So it does not work when you're trying to read from a file. So we do have to create a file object. So file, and I'm going to name this file, equals new file. Then we put in our file name, sample.txt. All right. We do have to import files, so Control-Shift-I. And you see it's in the java.io.file package. Okay? So when you're using a file, you have to use java.io.file. All right. Then, in our scanner, we pass our file object. And you notice now we have an error. What is that exception that is thrown now? FileNotFoundException. So if that file doesn't exist, which I thought should have happened before, it's going to throw an exception. And it's forcing us to catch that exception before we can even go any further. So we have to catch that exception. So inside of our if statement, we can do a while. All right. And then a break statement afterwards as well. Okay, so what am I going to do here? So what's going to happen is I'm going to try this stuff. Okay, so try to do this. Everything works as expected. Break this while loop. However, if we catch a file not found exception, ex, system.out.println, file, the file, plus file.get. Let me put this out here so I can access it in my try. The file, and then I'm just going to say file.get name does not exist. System.out.println, please enter another file name. String file name equals input.next line. File equals new file, file name. All right. So I wrote all that code. Before I explain it, can anybody tell me what that code is doing? This code that I wrote starting from line 28. I'm just creating the file object at that point. I haven't done any reading yet. I imported, so in order to use the file class, you have to import it. File object, yep. Mm-hmm.
While the statement is true, while it still works, you're trying to read in the file.
It's just like when you use in.next line. I'm just reading the next line from the file. Reading, right? Well, we're reading the file. We're reading a line. That's just us reading in a line. Just like when we read from the console, we do in.next line. Well, my scanner is named reader, so it's reader.next line.
And then while you're trying to read in the file, and then string line is reading each line of the file.
Correct.
I'm not sure what the break does.
It breaks the while true. Right? If we're able to read from the file and there's no exceptions thrown, break the while loop. Yep. Yeah. Well, somebody else can take over. What is 38 doing in 39 and 40 and 41?
The system that printed it out. So, in quotations, that's just like what you're calling it. Plus, file that get name. That's you.
Getting the name of my file object, like the actual file's name, right? The file on the hard drive, its name.
So basically, the name of the file is not in this.
Right.
That out to the user so we know.
Right.
Another system of that print. Often you could enter another file name.
Yep.
String file name. That's the same. String file name.
We're reading a file name from the console. A new file name.
You're reading a new file. The other file that the user is going to enter.
Right. And then for my file object, I'm setting it equal to a new object, right? Right. I'm setting the file variable to a new file object using that new file name that the user just typed in. Right. So again, to recap, I create a file object and variable appear. So I named it lowercase file equals a new file object pointing to a file called sample.txt. It can exist or it doesn't at this point. Just creating the object doesn't tell Java that it exists yet. Then when we try to create a scanner to scan this file object, Java is going to say, well, if this file doesn't exist, we can't create the scanner for you. So if that line fails, I wanted to go down to the FileNotFoundException, the catch, tell the user the file, and then whatever the name of that file is, does not exist. Then prompt the user to enter in another file name. We read in the new file name, and then for our variable, we set that equal to a new object using the file name we just read in. So if it makes it easier to understand this, new file name, new file name. So that's the new file name. FileNotFoundException, I believe we might have to import that. Yep. So I had to import FileNotFoundException, that error goes away. And now we have our code. So let's see what this looks like running. So I'm going to put sample 1. We know sample1 does not exist. Sample.txt exists, but sample1.txt doesn't. So let's run this. Would you like to load from a file? Yes, and when I hit yes, it's going to go here, create our file, while, and then try to create a scanner for it. And it's going to print out the file, sample1.txt, does not exist. I know it's really small. Please enter another file name. I type in a file that exists, sample.txt, and I guess sample.txt doesn't exist either. So we got to figure out why it can't read from sample.txt. Parentheses.
Next time, probably if you did that, parentheses, it would be red.
Yes.
What's the statement? Every time you start, I'm trying to word.
Start what? A method. A method. So the error is we have to put these files into our project root, which is where our main project folder is. All right, so my main project folder is com.mycompany.lecture5. So you have to put your file there. It's a little requirement of Java. So again, whatever your sample file is, put it in your project root, which is the first folder for your project.
So we got it where it was.
Yeah. Yeah. So let's try to run this again. Hit yes. It's going to say the file sample1.txt does not exist. Please enter another file name. I'm going to say sample.txt, and it works now. All right. Sample.txt exists because I put it in my project root. So it's a requirement that it has to be in the project root folder. So now it works. If you don't have it in your project root, you can put it anywhere on your file system, but you have to know the entire path. That's why when we we load things, they typically don't ask you to type in the whole path. What do? They give you a nice little GUI to click on that pulls this up. When you pull this up and click on a file, and the program, whatever program you're on, tries to read that in, this file chooser supplies the absolute path to that file. So that's why you don't have to type in the absolute path. This file chooser does it for you. It makes us as users, our lives a lot easier. All right. However, if we're coding it, hard coding in a file, we have to know the entire path. Okay.
So is it just going to keep looping? Because mine just keeps looping now every time I press Y. Like it just.
Do you have this break statement right here inside the try?
Yeah, right after. Yep, I got that one.
Do you have this break statement?
Right after the catch.
Right after the catch, yeah. You need two breaks. So this break statement breaks this while loop.
Okay.
This break statement breaks this while loop.
Oh, all right.
So this while loop is for just reading in the file if you want to or not. If they put an invalid input, it loops back up.
Okay.
This while loop right here checks to make sure that file exists. If it doesn't, then it loops back up. So we have two while loops. And if you all see now, the structures that we have learned, we're starting to use them in creative ways. We have a while loop embedded inside a while loop. We have a try and catch embedded within the while loop that's embedded within a while loop. And then we take this even further. We have a try catch embedded within a while loop, embedded within an if statement, embedded within a while loop, embedded within a method in a class. So all these concepts we've learned, now we're putting them together to accomplish. Honestly, we use this type of thing every day. We load, we write to files, we save all the time, every day. Now we're actually learning how that is done. How do they accomplish it? Okay? So we read from the file. So how do we get this program to read each and every line? What do you think we need to read every line in a file? What repeats itself? A loop. Which loop do you think we should use? A while or a for loop? A while. We don't know how many lines are in this file. Right? When we start reading, it always starts at the top. So you don't know how many lines are in this file until you start reading it. So a while loop, again, we don't know how many times it's going to go. So we can say while reader, a while loop within a try, within a while, within an if, within a while, within a method. It just all depends on what you're trying to do. You know, if there's code you need to loop, you need a loop. If there's something you're trying to check, you need an if statement. If you have code that can throw an exception, you need a try catch. You said what? Is it 150? I got 102 so far, but I don't have the display details method. Nor do I have the createAuto method. I don't have any of that. So I can imagine this is almost 200 lines, yes. But if you look at the program, in the grand scheme of things, this is not the most complex program out there. We read, we write, eventually. We create an object, we store it in ArrayList. Outside of that, we're not doing much more. Think about the programs we use every day. What went into building those? They don't do it overnight, trust me. Yeah. It's one, when I created it, it was one big file. Now, I think it was several thousand. Let's look it up.
And they still update it.
Yeah. Let's look it up once we finish with this. So read while reader dot has next line. So while this reader, this scanner, has another line to read, read in the line, string line equals reader.next line. And then for this program, I'm just going to print it to the console. System.out.println line. I'm just going to print that line to the console. And when it's finished, I'm going to put a little space in there. All right. So what did I just do here? So again, we have our scanner right here. Our scanner is designed to read from our file, or read from whatever we put in this parenthesis. For this scanner, we put a file in there. Therefore, we have to try and catch the FileNotFoundException. Once we get past that, you know, that's kind of the basics you need in order to read from a file. We have our while loop. While reader.has next line. What does this do? Checks if the, I can't spell it. The scanner has another line. If it does, continue looping. This right here creates the scanner for our file object. I'm going to capitalize file because it's a class. This right here reads in the next line and stores it in the variable line. This code right here prints the variable line to the console. I would get in the habit of writing comments, and I'll start writing comments for you all as well, because when you start creating programs, your fellow programmers will thank you. the try catch required for file not found exception. Break statement down here breaks the while loop for file not found exception. The catch catches the file not found exception on line 34. Tell the user the file doesn't exist and prompt him for a new one. Read the new file name in and store in variable new file name. Set the variable file equal to a new file object. Pointing to the new file name variable on disk. All right. So that's all of our code that we've done today. So we've, just a little bit. It's a little bit of code. This one here, create the file object. It's just a little bit, you know, nothing too crazy. All right. So this is all the code that we've done today. So when I run this, what do you expect to happen? What do you expect to happen if I run this code? Why? Oh, prompt the user. Okay, yes, yes. And then what? Yep. Yep. And what if the file exists? Each line within the file, yeah. And that's on statement 42, line 42. That's where we actually read in the line from the file. And then we print it out to the console, and then it repeats that as long as there's another line to read. So I have an error somewhere, I guess, or do I? Oh, all right. All right, would you like to load from the file? Yes. The file sample1.txt does not exist. Please enter another file name. So sample.txt exists. And when we read in sample.txt, it reads each file, or each line, I'm sorry, and prints it to the console. Once it reaches the end of the file, this while loop stops. Go ahead. Go ahead.
You said the file sample.txt.
Right. Right. I coded that in.
Yeah.
I coded that mistake in up here, purposefully. I knew sample one didn't exist. I was just checking to make sure my catch works. And then I typed the actual one that did exist. Now, normally, yeah, I would prompt the user to enter in the file name, right? So, and then we'll modify that in a second. But I just wanted to make sure that my catch was working. All right, so once it does have a file that exists, it goes here. While the reader has another line, it reads in the next line and prints it to the console. This is what you see here. Each line was printed to the console. Once it reaches the end of the file, it stops. I printed an empty line here just to put some space. That's what this did right here. It put that space right there. Then I broke the while loop for the file not found. And then when it breaks that while loop, it goes down here and breaks the while loop to read from a file. Once it breaks that while loop, we go down here and we ask the user what they would like to do. So it's all logic. Where are you going to break the loop at? How are you going to break it? And then what's going to happen next once you do break it? Right? And at this point, you know, I can give you all a lot of direction on what you should do and try to do, but it's really now it's getting down to the point where it's up to you how you choose to solve your problems. Because reading from the file, this is one way of doing it, and I have if statements, I have while loops embedded within while loops, and you might decide that a switch statement is better. Or you might decide that I only need one while loop. I don't need all these other embedded while loops for whatever reason, I don't know. You know, so how you choose to solve your problem is up to you, and that's one of the beauties of programming. So before you go, let's modify this code to read the file name from the console first. So would you like to read from the file? System.out.println, please enter a file name, string file name equals input.next line. And then we just pass in file name here. And then one other modification down here in my catch, I don't have to use new file name anymore. I can just say I have a variable file name equals this, and then pass in file name again. That way, if they decide to, or they mess up or whatever, and they read in a new file name, the variable file name we can use in other places, and it's been updated based on what the user has typed in. Capital, you can, yeah. I think file name, you can get away with it being one word. So I run this. I need to close out some of these. I've got a couple other ones running. So I run this. I'm going to purposely put in an improper. Oh, let's check to make sure this works. Okay, that works. All right. Let's check to make sure file, random file name, make sure that works. The file, blah, 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 does not exist. Please enter another. Let's try this again. Does it again. Then we type in a file that does work, but I messed up one character. It does it again. Sample.txt, file that does exist. It works, and it moves on.
So tell me, Facebook made files like the basis of while
Yes.
if statements.
Yes. There is nothing else more advanced than what we're doing right now.
I keep asking that.
The basic, like the structures themselves don't change. Reading from a file, the only difference is instead of putting system.in, we put the file in. We just have to supply a try catch. So we've learned the fundamentals. While loops, if statements, switches, for loops, variables, what types of variables you want to use, try catches. Now we're just going to use other tools at our disposal built on top of those foundations. Reading from a file, loading and saving your work. Outside of that, nothing else more to it. It's just how do you choose to solve a problem? And a program is nothing but solving many problems within one program. If you look at this one, for example, our first problem was, how do we create a structure that can grow and shrink? Okay, I need an ArrayList. How do I read from the console? Oh, I need a scanner. So on and so forth. All right, that'll do it for today. All right, so the default, I had to create this because in the event, Java looks at this as compiled. In the event our case is not within these three options, A technically would never have been initialized. But we know that when we get to this method, we've already checked to make sure, so we know it'll work, but Java is saying, hey, if it never is one of these, it's not gonna work. So I had to make a default statement and initialize A here. Although we'll never go into this default because we've already checked to make sure the user has typed in a 0, 1, or 2 back in our main. All right, since I know all of these are technically automobile objects, that's the superclass, by default, they'll all share the same three characteristics. So what I'm doing is reading in those three characteristics for A, regardless of what type it is, because they all share those three characteristics here. So if it's a base automobile, I would stop here. If it's a car, I would still read this in for the car, but then keep going. Same thing if it's a truck. Okay. All right. So then what I did here is I made another variable in here. So in order to access the car's unique characteristics, I had to create a variable that is of type car. So I create a car, and you see I'm casting my object A into that. That's a type of polymorphism operation. I'm basically saying, take A, which to Java is just a base automobile, but we know if A is instance of a car, we know it's a car. So in order to access those car attributes, I have to create a variable that's a type car, and then cast A to that. So in memory, they actually point to the same object. The variable A, you can only access the automobile characteristics. The variable C, you can access all the characteristics of a car. So it's a little polymorphism wizardry here in order to access the car's unique variables. If I just stuck with the variable A, I wouldn't be able to access the sunroof, the spoiler, or manual. I'd only have access to make, model, and number of doors. But again, if this if statement is true, that means A is technically a car. The user chose option 1. So A is a car. We know this. When we get here, we're checking if A instance of car, then create a variable pointing to that object in memory. So now I can do C.set sunroof, C.set spoiler, C.set manual. I have access to the car's variables, more than just automobile. So let me back up a little bit. Up here, A is just an automobile, but I know all three of these objects share the same three characteristics, which is the superclass characteristics of an automobile: make, model, and number of doors. So I read that in for any type of object. Any subclass, I'm still going to read this in and set it. Then I'm checking, is A an instance of a car? Is it a car? If it is, I need to create another variable pointing to my object in memory, and then read in the characteristics for a car. Else if A instance of truck, I do the same thing for truck. I create a truck variable, but you see, what I have access to for a truck is a little bit different than what I had for a car. So this just allows me to access the different characteristics for those unique objects. Okay. There's a little bit of polymorphism that I don't think I covered before, because we're not going to really use it that often in here, based on how you wrote your methods. How I chose to write my method, I didn't want to repeat code. So this code, if I had everything in a case, a switch, this code would be repeated for all three types of objects. Like I keep saying, programmers are lazy, and as a coding standard, or something we like to follow, is not to repeat our code verbatim. So in an effort not to do that, I create one object, read in the characteristics for that superclass object, and then I just check if it's a subclass, read in the characteristics for that subclass. And because this variable C right here points to the same object in memory, I'm modifying the same object all throughout this method. So in essence, there's only going to be one object that I create, ever. I'm going to create up here, and then down here, I'm just going to modify it based on what type of object it is. Okay. Now again, you don't have to code, you don't have to make your method look like this. I'm just explaining how my thought process, my logical steps of execution are for my program. I don't know what I did. All right. Then I return A, and that's it. I only have one return statement, that's it. Now, for some of you all asked, what do I do if a user types in incorrect input within this method? Right, so for example, they type in a string right here for number of doors. How do I protect against that? Well, you can do it while for this only. Now, it might not be efficient while true. Try this. Actually, I don't want to try. I only want to try that statement. I don't want to print this out multiple times. I'm going to try this. Catch. What was it? Number format exception? X. System.out.println. Invalid input. Integers. Whole numbers only, because users don't really relate integers to anything. Whole numbers only. And close my while loop. If this statement goes through without a problem, we break the while loop. So you can do this to make your code responsive within your method. But you would have multiple while loops per item. So for example, down here as well, with this, Control C. So this one, I'm not doing any conversion, so that's fine. But they could type in something that's not a Y or something that's not a Y or an N. So we could do while true. If those are fine, we're good. Else, system.out.println, invalid input, Y or N only. Then I do need to read in a new ns equals input.next line, a new value. If not, I'm just going to keep the same value. Same thing up here. Well, actually, this while loop is fine. Here, if it works fine, we break. If it works fine again, we break. And again, you could do this for all of these throughout your method. I'm not going to sit here and do all of this, but you could. This one, I am going to do this just in case they type in something. Try, that's a while. True. Try. Just in case they type in a number here. But again, depending on how you want to code your program, you can modify it to your heart's content. Make this as responsive as you can. All right, and that way, each one of these, we're checking to make sure it works. Each one, we would check to make sure it works. Okay. So that's creating an automobile. I'm going to do my public static void display details, ArrayList, automobile, autos for int I equals 0, I is less than autos.size, I plus system.out.println autos.get I.toString. Actually, I don't think I have toString methods, so it's going to print out some weird stuff. I guess I'll make those real quick. I have this one. So let's do car. Public string, toString, string RTR equals super.toString RTR plus equal new line roof plus this RTR plus equal, actually I think boiler plus this boiler R plus equal manual plus this dot manual. All right, return RTR, and then the truck. Truck one has 1, 2. And unnecessary. All right, so I have all of my toStrings now. That's a lot. So I did my createAutos, I have my display details method. Okay. And I think, yeah, these ones I have to fix. If choice equals 2, I don't think I want to. Let's add, remove, okay, switch. And then case 0 is when they want to add. System.out.println, which type would you like to add? I'm just going to say 0, 1, 2. We know what those options relate to. So that's just a string. And then we win a read in string choice equals input dot next line. Actually, I think it's an int. Int choice equals integer dot parseInt input dot next line. While true, no, while choice doesn't equal 0 or choice doesn't equal 1 or choice doesn't equal 0. So while any of those are true, system.out.println invalid choice. And then choice equals integer dot parse int, input dot next line. I don't think choice is going to work because I already have one. Auto choice. All right. What's my array list? Autos. Create auto choice. All right, remove. I think remove is fine. And then system.out print line, display details, autos. All right. This should look exactly how I don't need to system.out. Just call the method. This should look like your programs up to this, to a certain degree. How I did it might be a little bit different, but it has the same functionality of what you all have done already. So I can create, I can delete, and I can, in my program, print out. I can read from a file, yeah. And I haven't actually done that code yet. So. And then actually, we might run out of time today to do that. So I'd prefer not to. I could just modify it. I want to add, what type would you like to add? A 0. And my code isn't working. The invalid choice shouldn't be printed out. Oh, I know why. This should be ands. So all of these have to be true in order for it to move. Anyway, you said what? Yeah, you're right. All right, so there we go. All right, so let's figure out how we're going to read in the options from here and add that automobile to our file. Okay, let's say we have, add it to our array list. Let's say we have a file. The format of that file is our toString methods. And actually, let's do that first. Let's write to a file, and then we'll learn how to read it in. Because I want the same format as what we write to the file to be. All right, so let's learn how to print to a file. So instead of display details, let's say save details. So instead of this, I want to say system.out.println. Would you like to save your word? Y or N? String save work equals input.next line. If save work two lowercase dot equals a y, we're going to call our method save details. All right, that's what the method we're going to call. Else display details. I know. That's what we're going to do. Save details, we're going to pass in our array list. All right, so let's create this method to save to a file. All right, basically we're going to save just like our displays. Okay. So let's start off with our method signature, public static void save details. We're going to pass in our array list again. We have our method header, our method signature. Okay. Whew. All right, we have our method signature. It's very similar to our display details. To save to a file, we're going to use something called a print writer. a print writer object. All right. So we obviously, just like when we read from a file, we need to create a file object to do that. So let's ask the user what name they want to save it to. System.out.println. What do you want to name this file? String. So in order to read that in, we need a scanner. Input equals new scanner system.
So like the auto, or what is that? Like, so bundle so like, what is auto?
That is your array list that you're storing everything in.
That's the name of the array list?
Right. When I get to this method, the alias to that array list will be autos. This is passed by reference, meaning the array list that you create at the top in your main, when you pass it to this method, the alias for it in this method becomes whatever you put up here. File equals new file name. All right. Then let's create our print writer. And actually, I don't think, let's see. I'm going to name this writer equals new print writer. I don't know if we need to make a file. Control-Shift-I. All right, so you see now I have some underlined code. What do you think that's underlined code is? Just like when we read from a file, what do you think I need to do? I already imported it. Just like when we read from a file, what do you think I need to do? What did we just learn last week? Last week. What protects against exceptions? A try-catch. FileNotFoundException hasn't been caught. And so I think instead of putting the file here, I think if we just put the file name, we still have to catch it, so it doesn't matter. So we can just obviously put surround statement with try catch. And it's going to do it for us, except it depends on what you want to be printed or to be done when you catch the exception. This one, it says it's going to put a logging error, but your program is going to stop. I want the user to type in a new file name. So I'm going to put all this into a while loop. All true. And then if everything goes good, break the while loop. Right? If everything within our try works, break the while loop. If not, start over. And instead of saying this, I'm going to say system.out.println file does not exist. And then it's going to ask, what do you want to name this file? Yeah. So we have our print writer. So just like when we print to the console, you'll use the exact same methods in the same manner, except instead of printing to the console, we'll be writing to a file. So what does that mean? Just like when we print to the console, we do system.out. Let's do our for loop to loop through our array list first. For int I equals 0. I is less than autos.size, I++. And then we want to print to the console. Let's do system.out.println autos.getI.toString. All right, print to a console, no problem. Right? This should look familiar. You have this in your display details method. Okay. The only difference between what we have here and writing to the file, instead of system.out, you type writer. That's my print writer object. Once you are completely done writing to a file, you want to do writer.flush. That actually, essentially, like you think flushing the toilet, it flushes all of the text you're trying to write to the actual file. And then writer.close. There you go. Now, what you'll see a lot is people will have a finally clause down here and do writer dot whatever, whatever, but to keep it simple, we're just going to keep it up here in our try. So the print writer, again, that's writing to the file. At what file? Well, the user types in a file name. We create a file object. We put that file object into our print writer. It's going to create, if the file doesn't already exist, it's going to create a new file for you on your system. We loop through our ArrayList. Instead of doing system.out, which prints to the console, we do writer.println. And then once we've done all of our printing, we want to flush our writer and close it. That's it. That's the only difference, other than having the try catches, than when you do printing to the console. Instead of system.out, you do writer, or whatever you name your print writer, .println, or .print, or whatever method that you typically use with system.out. Any of those work. So what will this look like when we run our program? All right, let's see. Make sure I don't have any errors. Any questions?
No questions.
This is what? All right. That's my save details method. And you see why methods come in handy. If we had all of this code in our main would be how many lines of code? 250 lines of code. This is our app file. But when I say main, I'm talking about the main method. So the main method is this right here.
Oh, you mean inside that one thing?
Right, inside the main method, this is what I have, and it stops here. But everything else, because it does unique things, and we can reuse it if we wanted to, I put all of those in their own individual methods, and I just call them for my main. So if you wanted to, you could even reduce this main even further, which is what I would normally do if I was writing a real program. Right. So I would put the reading in part, reading in a file, in its own method. Right. Now I ask if they want to. If yes, call that method, which is what we'll do if we have enough time. I would do this part in its own method, determining what they want to do over and over again. I would put that in its own method. It's okay the way it is. All right, let's see how this works. So do I want to load a file? No. What would I like to do? I want to add, which type is 0. Please enter the make. Ford Mustang 2. Oh, I chose 2. Hold on. Somewhere I didn't ask for input again. So up here in my main, I didn't ask for their choice again. I didn't read it in again. Yeah, I did. Okay, so here, I didn't read in the number of doors. Yeah, I did here. Nope, I would have to debug this. Crap. Now we're running out of time. No. Add, which type? Automobile. Okay. Please enter the make. Ford. Model. Mustang. Number of doors. 2. Then what? Oh, I got to hit enter. It breaks the while loop. That's false. That's false. Return A. Add that. Oh, here we go. I don't have my break. That's why debugging is so good. You can figure out what your logical issues are. I didn't have my break statements in my cases. This break right here? Break? Yeah, break will break whatever surrounding structure you have. So it's breaking the switch. Or you can break the while loop. So stop the while. You can't break a try. It switches while loops. Or for loops.
The try should be within a while loop.
You can put it inside the while loop, but that break statement will still break the while, not the try. All right, so let me rerun this, because I want to get to where we print this out at the very least, and then I can talk about reading it in on Friday while you do your math. So I don't want to load. I want to add, which type, 0, Ford, Mustang, 2 doors. Now what do I want to do? I want to add a car. It's a car. Chevy, Camaro, 2 doors. Yes, yes, yes. 0. Another car. Dodge, Challenger, 2 doors. Yes, yes. They don't come in manual. One more. I'm gonna add a truck. Ford F-150. First bed length 6.5. No, no. And then I'm going to end the program, and it's going to ask me, would you like to save your work? I'm going to say yes. What do you want to name this file? Autos.txt, and we finish. Cool. So then you ask, okay, what just happened? Well, when we go down to our save work, you saw it's going to ask, what do you want to name this file? I put autos.txt, and then it actually prints to that file. Remember, the file is going to be in your project's root folder. So basically, your project folder. My project is on my desktop. I think it's this one right here. And you see autos.txt right here. I will in a second. What did we print to autos.txt? The toString for each automobile. Right? So for the 2 cars, or 3 cars, and a truck. So there should be 4 automobiles in that file. Let's see. Yep. 2 autos. One is just a base automobile, if you remember, so it didn't have all the characteristics of a car. These 2 do have those characteristics. The truck has its own characteristics. So we just wrote to a file. Okay. Now I'm going to make this a little bit better. These 2 strings, I'm going to add what type it is first and foremost. That when we actually print to the file and we read through it, we know which type it is. Okay. Actually, no, not here. This one, file not found. Actually, I'm going to do it here. So if a instance of truck, well, let's say car. I start with car. Writer.println autos.getI instance of car. Else if autos.getI instance of truck. I messed up there. Writer.println. Here I want to say truck. Else, if it's not a car, if it's not a truck, it's just a base automobile. Writer.println automobile. Here I want to say car. Okay, let's do this again. Let's delete this file, or I can keep it either way, but it's the old format. So when you actually run programs and you try to load something or something and it's saying, this was created with an older version of this software. Basically, they just updated how they save to the file. Right? And they know, they keep track of what the old version looked like and what the new version looks like. If it reads it in without the new version's characteristics, it's going to say, update your software. You're still using the old software. Right? So Microsoft Word does that. And it'll allow you to convert it from Word 98 to Word, I don't know what the newest one is, but 2020, I guess, which is the newer format. It's just how they updated saving their files, how they wrote to the file. So now you see every program that you use breaks down to these basic code, to this basic code. Saving a file is all up to how the programmer decides to save that file, what format they follow. Yeah, I'm about to run it. I'm not going to load right now. We're going to do that starting on Friday. I want to add base automobile, Ford, Mustang, 2 doors, add again, car, Chevy. Yep. It's car manual, yes. Add another one. Dodge, Challenger, 2 doors, sunroof, spoiler, no. Add another one. Truck, Ford, F-150, 4 doors, 6.5, no, no. In the program, yes, I want to save, autos.txt, save. So let's look what our new autos.txt looks like. It should have whatever type that vehicle is and then the actual vehicle. You see the base one was just an automobile. This one is a car. This one is a car. This is a truck. This comes in handy because when we read this file in, we need to know what type of object we're creating. And if you notice here in my code, that's what the instance of does. If it's an instance of a car, it writes car. If it's an instance of a truck, it writes truck. If it's neither one of those, it must be, there's only one other option. It's a base automobile. So it prints automobile. That's what you see up here. We have a file, autos.txt. So on Friday, we'll learn how to read in the characteristics, or read in from this file, and then create objects and store those into our ArrayList. We learned how to read from a file last time, so if you want to try to do this before you come, by all means, basically all you do is read each line. If the line equals automobile, create an automobile object. The next couple lines tell you the characteristics of that automobile object. Then read another couple lines. If the line equals car, you know the next couple characteristics are going to be for a car object. Create the car object, read in those characteristics, add that object to your ArrayList. Same thing for truck. If the line equals truck, the next couple characteristics are going to be for a truck object. Create that truck object, read in those characteristics, add that truck to your ArrayList. Once you've done all that, you can add and remove as you did like before. So that's what we'll do next time. If you want to try to do it before we come, by all means, that's going to be your lab. So I would encourage you, just so you don't take too much time on Friday working on this. All right, that'll be it for today. How you doing? What we have so far. So we go up to my main. And you see this file is starting to get pretty long. And so when we talk about our main, again, we want to try to make our main as condensed as possible. So some of the stuff we have in our main, we can actually pull out and put into methods. And I'll do that before we get started with the reading. So just to recap our main, this code right here, if you remember, was to ask the user if they wanted to read in a file and then read that file in. That's what all this code did. So again, to better organize our code, and since we already have a save details, let's create a public static void read details method. And that's just going to read in the details. And so in our main, we're going to ask the user if they want to read from a file. So we're going to keep that code in here, but I'm going to take out all the code that relates to reading in. So all of this stuff, all the way down to, you said what? I'm not deleting it. I'm going to take it out, and I'm going to move this down into a method to better organize my code. All right. So that's what I did. I just moved it from my main, and now it's getting our main to be a little bit smaller. Actually, I need this code too. The break stays in the main because that breaks the while loop for their input. You can just do Control Z. That's undo. Everything inside this if statement except for the break. Everything except for the break. Yeah, everything. Yeah, because that relates to reading it from the file.
What about the read choice?
Read choice stays in the main, right? Because that's related to deciding what the user wants to do. Right? Everything else looks good in here. So in your main, I've left everything that relates to asking what the user wants to do with our program. So do you want to read or not from a file? Okay, go on to the next. What do you want to do? Add, remove, or exit? Whatever they want to do. If they want to add, I create the createAuto method. If they want to delete, I want to call the delete method. And I'm going to write a method for that. Brackets, public, static, void, delete, auto. I never made it. You should already have one. Yep. And then I'm going to move this method. What the code I have, I'm going to move this down here. I'm going to say, yeah, I'm going to move all this code down here. I'm going to create a scanner. You said what?
Instead of return no, you have return
I've returned A.
Right there.
Yes. Yeah, remember my method is a little bit different because I created my object up here with polymorphism. So again, yours doesn't have to look exactly like mine. If it works, it works. What's wrong with this? Oh. All right, source format. Okay, this is my remove. In my main, case 0. It's delete auto. Yeah. And I'm going to move this stuff into my add auto method. And I'm going to actually make this as clean as I can. You already should have one, if I'm not mistaken. You should already have one.
I tried to make a read detail,
You can, but I prefer you to better organize your main.
my whole thing was red, so I don't know what I did wrong.
It's your bracket somewhere. I'll come look.
I just wait until after.
Okay. All right, so you see in my main now, this switch statement, it's only if they choose to add inside the case 0, I'm just calling a method. Case 1, I'm just calling a method. The default, they didn't put in the right input. I think I still need numbers format, but I don't need index out of bounds anymore. I don't need any of these actually. I just need number format for this try. Now I do need to put this in a, right here in a try catch. I could do that. I don't feel like doing it right now. Same thing with my read details, I believe, or delete. It could be an index out of bounds here, but I'm just going to leave that the way it is right now. All right. So my main is a lot shorter now. My main is only 60 lines of code instead of, or maybe 50, instead of however long it was before. So in this if statement, if they want to read from a file, I'm going to say load details. I'm going to pass in my autos array. Is that read? I name it load details? Read details. I like load just because that's what we're doing. Load details. All right. I need to put an argument here. I need this array list because when I read stuff in, I want to add it to the array list. And if you remember, array lists are passed by what? We have passed by reference and passed by value. Which one is an array list? We have passed by reference and passed by value. Which of those is an array list use? Remember, pass by values, you make a duplicate in your method. Pass by references, you can modify the same thing, it's just an alias. So you're modifying the same thing in memory in your method and wherever you call it from. So that autos array list, wherever we pass it in our whole program, it'll be the same array list over and over again. Whereas if it was passed by value, if we modified it in a method, it wouldn't affect the same one in memory. So we use it in one method, and we try using another method, it would be two separate array lists. Now we're passed by reference, we modify one method, we use it in another, those modifications are ported in. It affects the ArrayList that is in memory. Same thing goes for arrays and objects. So load details, I just copied and pasted all of my code into this. And if you remember, this code just reads the file and then prints out the contents to the console, I believe.
So the load is the same as reading the file.
Right. And so let's read our file. And if you recall, our file was, I think, autos.txt. Let's see, or maybe sample.txt. It's autos.txt, right? So this is our file. Let's start our program and let's see what it looks like when we read. Yes, autos.txt. You see it reads in all the details. That looks like just like when we did our toString last time, right? Because it is. If you recall, we printed out the toString for each one of these objects. Everybody with me so far? All right. All right, and you see now it read the file. We haven't done anything with this, and then it continues our program here. It asks our user what they want to do. So everything is working so far. So now what do we want to do? Well, we want to read our file, and then depending on what the contents say, create the objects and read in the information for that object. Okay? So how can we do that? Well, if we look at our file, the format is whatever type the automobile is, we read in that type, and we start there. So while reader.hasNextLine is going to keep going. String line equals reader.nextLine. So what do we need to check for? If line dot trim trims any spaces at the end, any new line characters, dot equals automobile. I'm going to say automobile A up here. We're just going to have one reference.
It has to be a .txt file.
It doesn't have to. It could be whatever format you want. It could be autos dot my custom file.
So I never made it so like sample file, right? I just try to go regular file.
No. You have to go off. So you have to know the format that that file is written in or read. So you have to know the format if you want to read it. Right? So if you don't know the format, you don't know what you're reading in. That's why when you have different programs, Word saves their files as .wordx, I believe. And when it reads in .wordx, it knows how that's formatted and reads it in accordingly. So you don't know, at least I don't, I'm not a Word programmer. I don't know the format in which WordX files are saved. So if you opened a WordX in a text editor like Notepad++ and actually looked at the contents, I think it's gibberish. But the application that somebody programmed, Word, knows how to read that gibberish in.
So sample.txt.
Right, or we can name it sample.l15. Like whatever extension you want, because it's only relevant to your program. Right, you have to create the file.
I saved this.
Where it has to be in your project folder. So this is my project folder. It has to be in your project folder. You should have a project folder. How do you submit your projects? All right. So we read in the line. If that line equals automobile, right? I'm saying trim and two lowercase just to be safe. Automobile. Then A equals a new automobile. So we read in a line, right? And that's why I added this into our safe save code so that we know what type of automobile we're creating. So if we read just the base automobile, we know we're just creating an automobile object at this point. If we read in a car, we're creating a car object. If we read in truck, we want to create a truck object. So to continue this if statement, we want to say else if line dot trim dot two lowercase dot equals. This is in, remember when we had the read code? While reader dot has next line. So that's going to keep going while there's a new line in our file. It was in your main, I believe, and you said you tried to cut and paste it and it broke everything. So the first, it starts off when we're asking them to please enter the file name that they want to read. Correct. And then if they said yes, please enter a file name. I just put this in a method. All right. So scanner, we create our scanner to read from the file. While that scanner has a next line, we read in the first line. All right. While it has a new line, we read in the line. So if we look at our file again, we read that first line, we know the information that's coming next is going to be for an automobile. So, excuse me, so we say A equals new automobile. All right. And then we can keep going from there. So we know the next line should be, it should say make and forward on that, or make and then whatever the make is. So we can say line equals reader, that next line. So we want to read in the next line.
So we got freaking all
Right.
So we multiply automobile A and then automobile other.
But remember, A is polymorphism. Right? Well, I'm going to use polymorphism eventually. So let's just work on the base automobile right now, and then we'll get to car and truck later.
Oh, all right.
So we're just looking at the basic car. We know, we read in the first line up here, if that line equals to lowercase automobile, we know we need to read in the information for an automobile. So I want to say line, we read in line equals line dot replace. So in this code, what do we want to replace? Well, I just want to take this part off. Make colon with a space. So we can say replace what string? Make colon, what do we want to replace it with? An empty string. So what this will do is it'll take this part off and just leave us with Ford or Chevy or Mitsubishi or whatever, BMW. Then we can say a dot set make to line. And actually we can do this a little bit. String make. All right. So we created this automobile object. We read in the next line. We know the next line is the make. Right? String make equals line dot replace that portion with an empty string. Then for our automobile object, we set its make equal to that string. So let's see what this looks like at this point. I'm going to put a break statement here. Let's debug this. I think it's going to ask, would you like to load from a file? Yes. File name autos.txt. You see, it stops at that line. My program stops there. So this is where we're at. Let's look at all the variables we have in this method. We have our autos array list, size 0. we have a scanner for the system.in, file name, we have a file object, and we have a scanner to read from the file. Okay? Is everybody with me so far on what I have? And why, where it stopped, and all the variables that we have at this point? We're doing the homework.
Yeah.
Okay.
I don't know why I started with this.
Everybody good? What's confusing?
Yeah, I don't even know. Like running, like what stuff I need to put.
Yeah, so I looked at the main and I just organized it how I thought it made sense. So if I look at the main, up here, we're asking the user if they want to read from a file or not, right? If they do want to read from a file, all of the code that I had in that if statement, I just moved into its own separate method. Because it's not really related to the user, doing stuff. It's more so a specific behavior. We are reading from a file.
That's another.
Right, that's where the load details method goes. And if you notice, I passed in the array list I created up here to this method so that when I do read in details, I can add objects to that array list. And then if I continue my program, I can keep using that array list, removing from it, adding to it, so on and so forth. It's going to be the same array list throughout this entire program. Because of pass by what? Pass by what? You said what? So when we use these array lists in different methods, we're going to use the same array list within all those methods. So one change affects it everywhere else. Because of pass by what? Pass by reference, exactly. Versus pass by the other one. What's the other alternative? It is numbers. Numbers are affected by it. Pass by V. Value. Pass by value. All right. Y'all have short memories. Good Lord have mercy. We just talked about it 10 minutes ago. It's not like I'm covering a lot or anything. Where do you need me to go? Right here? So mine, I called it low details, but you can name it details.
So, but it was from a file, right?
Correct. Correct.
Cat. Okay.
Everybody good?
That was good.
The else if we're going to talk about that later. So I made it earlier, but that's going to be for different objects. We're not done with an automobile because we still have to read in the model and the number of doors. So let's do the model. So line equals reader dot next line. So we read the next line. And we know, based on our file, that next line should be the model. So we're going to do the same thing. String model equals line dot replace. What do we want to replace? Model with a space. What do we want to replace it with? An empty string. We say a dot set model to that, what we just read it. What about what? So let's do that. So the next one is going to be the number of doors. Because I don't feel like typing all this, I'm just going to copy it. All right, so line equals reader dot next line. We're reading the line. It's going to say number of doors and 2, that whole line. So we can say int number of, let's just do num doors, equals integer dot parseInt. Right, but what are we trying to convert? Well, line dot replace What do we want to replace? All of that has to be inside parentheses. What do we want to replace it with? An empty string, semicolon. So it's going to read in that line right here. What we're doing is replacing all of this with an empty string, which should just leave us with this number right here as a string. Integer parse in is going to convert that last little piece into a number, and we're going to store that in our variable numDoors. Exactly. A dot set numDoors, numDoors. All right. And then all we need to do, autos dot add A. There we go. And actually, I don't have to declare this up here. I can just declare it here, because I'm not going to reuse it a whole bunch. And there we go. We just added our first object to our array list. Right? So then we want to say else if. So it's going to keep going, right? Our for loop is going to continue. It's going to read in a new line. If the line equals car, it's going to go here. If not, it's going to keep going. Else if. This one is going to be for truck. And we know that's all of our variables, all of our information. So let's take this out right here, because we don't want to print to the console anymore. That was just for our information as we were testing our code. And let's see what this looks like when we debug this. So output, would you like to read from load file? Yes. Autos.txt. We're stopping here. That's where I put my break statement. All right. Let's look at our variables again. To recap, we have an array list of size 0. There's nothing in it. We have a scanner for the console. The file name was autos.txt, as you see that over there. We have the file object, and we have our scanner that reads from that file. So let's step through our program. So now we're on this line. It's going to read in the first line from the file. That line is automobile, right? And if we look at our file, that's the first line. Right with me? All right. Then we're going to check if line.trim, trim just takes off any empty spaces at the end. At the end, and I think at the beginning as well. So we just get the content. It removes spaces. We're going to lowercase this to a lowercase automobile. If whatever that output is equals this, go into this if statement. It does. So we know at this point, we're going to read in a base automobile. Because if it was a car, this line would say car. If it was a truck, this line would say truck. All right.
How do you put that in?
Do what?
Make it so that we know what type of variable we're talking about.
So I think when I saved it, I did it here. So as I was saving everything, for whatever automobile I was about to save, I checked if it's the instance of a car, print car, this is the save details, and then print out the details of that vehicle. Else if it was an instance of a truck, print the word truck, and then print out all the details. If it's not a car or if it's not a truck, you don't need it. You can put it in your main. I like to organize my code in methods because it makes more sense to me. I can go straight to it and say, okay, what is this method doing? It's saving the details.
That's what we want.
Correct. And yes, you will likely need this because if you don't have it, how will you know what type of object you're going to be reading in? Yeah, you can just type it because you know how to how to do this.
Not paying with that.
You got 1 minute. Well, you need to learn. Yeah, that's the whole save details method. It's 10:35. You have 30 seconds. Wow. Well, type faster. Come on. We only got 15 minutes left. Again, it's not about you copying what I have. You need to learn what you're actually doing.
Once I type it here, lab, and I go into homework, I'm looking at it, and then I understand. Right now, I'm just trying to retain the information. Do something with it.
No, string, when we try to add to strings, that's a big word, string one. There you go. What is it called when you create an object? Instantiation, right? What are the 4 pillars of object-oriented programming? Brendan, what's one pillar?
Abstraction.
Jazir, what's another pillar? Jazir, what's another pillar? Polymorphism. Chris, what's another pillar? The abstraction, polymorphism, there's 2 more. Well, too bad you can find another one. There's one that starts with an A, and there's one that starts with an E. There you go. And finally, then, encapsulation. Now we're going in alphabetical order. Brendan was the first one. Chris was the second one. Wait, somebody missed one. I didn't hear one, actually. We missed one. But you said abstraction was the second one in alphabetical order. Yep. That's the one we missed.
That's what you said.
No, I know, but we missed the one that you're supposed to say now. The one, why would you give them that?
You said we missed one. I thought you were thinking.
What is it? Inheritance, and then finally, polymorphism. There we go. You done, Chris? It's been 3 minutes.
I need this too.
You said what?
I need this too.
Now, the tutor, again, will be in Yancey 130 at 3 p.m. today. So if you need help, he has gone through all of this. Yeah, I'll be here at 12. 12 to 2. Well, actually, no, I got a meeting at 12. Sorry. I'll be here at 1. All right, let's keep going. Okay, so we're loading in. We just loaded in our first, well, let's finish going through this line by line. So if it equals automobile, we know we need to create a base automobile object. So that's what I'm doing here. You see down here, we have our automobile object. All of the information is null, null, and 0. We haven't done anything yet. All right, so let's read in the next line. The next line says make :4. So then we create a variable string make equals line dot replace the make : portion with just an empty string. So you see down here, our variable make equals just the forward portion. Right? We took off make : space. We took that off. We replaced it with an empty string. So then for A, we set the make equal to that variable. You see now we have 4 in our object A. Let's read the next line. The next line says model and then Mustang. What do we want to replace? That model : portion. So now our variable model down here equals just the Mustang part. We set A.setModel. That's it. And then we read the next line. The next line, number of doors. Why'd it go away? It was number of doors. I don't know why it went away, but it was number of doors too. At least that's what it should say. So then we take it off. I don't know why it did that. That was weird. It was correct at a certain point. Yes, autos.txt. Go forward. All right. Back to our same variables. We read the next line. It's number of doors. Correct. And so now, num doors, we took off the number of doors portion. And now num doors is 2. I don't know why I keep switching to automobile here. Or model Mustang. I don't know why I keep doing that, but there's something wrong with the debugger. But number of doors is 2. We set a.set number of doors, and we look at A. You see the make is Ford, the model is Mustang, number of doors is 2. Then we add A to our automobile, to our array list, I'm sorry. We keep going. While the reader has another line, it does. We read the next line. The next line, according to our file, is just an empty line. So it's going to skip that, skip that, skip that. Then we read in the next line. Car. I don't know why it keeps going back to model Mustang. Yeah, see, there's an issue with the debugger. So let me stop this and rerun the debugger.
I got an error. Configure add check return value.
For which method?
So that is the LCF.
You said, what does it say?
It's not configure add check return value.
Configure add check return value.
Maybe I got extra.
Sounds like that.
Yeah, it's expected. I got it.
All right, so you see that line, the second line, or the line after we read an object is just empty. So you notice over here, our variable line is just an empty string. It's going to skip over all of these and go back to the top of the while loop. Then it's going to read in car. So what happens? It'll go inside this else if. We would create a car object, read in all the information, and then go from there. Next line, Chevy. So this is all stuff for the car, and so we need to read this information in for the car. So let's do that. Now, the thing to note is, when we read this in, we're going to be reading in the same information, make, model, and number of doors for each type of automobile. So, in an effort not to repeat ourselves over and over again, what can we do? We can use polymorphism again. All right. Now, I'll modify my code to do that later on, but as of right now, we'll just stick to copying it over and over. So I'm going to copy this code down here. But we know if it's a car, we don't want to create an automobile, we want to create a car. What? Yeah, I just copy and pasted that code down there. C, 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 C. All right. So make, model, number of doors, we know that that's consistent across all automobiles. So car has those. But if we look, car also has sunroof, spoiler, and manual. So let's read those in. Line equals reader.next line. So this should be sunroof. So then we'll say string or boolean sunroof equals boolean dot parse boolean line dot replace. What do we want to replace? That stuff. What do we want to replace it with? Empty string, semicolon, c dot set sunroof to that variable. Then we can keep doing this. I think the next one for a car is spoiler. C.set spoiler to whatever we read in. The next thing for a car is if it's manual or not. Let's read that in. Manual, manual, and then C.set manual to that variable. So you see how we save to the file, or how we read from the file, is predicated on how we saved to the file. We just follow our own format, which is our two-string methods. We're just following it in reverse order. Instead of writing it to the file like this, we're reading it from the file like this. And when we read it from the file, we convert it to a variable. If it's a string, great. If it is a Boolean, we convert it. If it's an integer, we convert it. We add all that information to our objects, then add our object to our array list. Everybody good on color?
Just quick, when you put the else, is it a new variable letter? Like you put C equals new automobile? Yeah.
Car C equals new car. Because we want to create a car object at this point. So same thing for truck. Yes, it's the same array list. Exactly, same array list. Because that array list, since it holds the superclass, you can put whatever subclass object in. Right. Truck T equals new truck. So if it's a truck, they want to create a truck. Make, model, number of doors is consistent. The truck has bed length. And that's a double. Line.replace. Ooh, all that stuff. What is going on here? What in the world? Copy. All right, so something is going weird. So I'm just going to type it out. Bed, then space, where we want to replace it with an empty string. Let me say T dot set bed length to that variable. A truck has tailgate, unnecessary tailgate. We want to read that in, paste it here. I don't know why it's not copying and pasting. Unnecessary tailgate. And then we say T.set unnecessary tailgate to that variable. And then unnecessary grab walk. So the new Hummer can move like diagonally. They call it a crab walk. Yeah. Like if you're parked here, you can move like this. The wheels turn. All four wheels turn. It's unnecessary though. Like, when we ever use that? It's a cool feature.